Hello all, my name is Aditya Shanmugam and my project is all about eye tracking devices. Eye tracking is a technology that allows us to measure where a person is looking. It is also a way to measure where a person's eyes are focused. For example, eye tracking can be used to measure how long a person looks at a particular advertisement on a website. Eye tracking can be used to track a person's gaze. For example, eye tracking can be used to track the gaze of a driver while they are driving. This information can be used to identify potential hazards and make recommendations for improving driver safety. Eye tracking can be used to measure a person's visual attention. For example, we can use it to measure how much attention a person pays to a particular product in a store. This information can be used to improve the placement of products in stores. Eye tracking can also be used to see what a person is looking at on a website. This information can be used to improve the design of the websites and make them more user-friendly. Eye tracking can be used to understand how a person interacts with a video game. This information can be used to improve the design of video games and make them more enjoyable to play. It can also be used in understanding user behavior. Eye tracking can be used to understand how users interact with apps, websites, and other digital products. This information can be used to improve the user experience. Eye tracking is also being largely used in diagnosing and treating eye disorders. Eye tracking can be used to diagnose and treat a variety of eye disorders such as attention deficit hyperactivity disorder, ADHD, dyslexia, and autism spectrum disorder. And we can also use eye tracking for controlling devices with your eye. Eye tracking can be used to control devices with your eyes, such as computers, wheelchairs, and prosthetic limbs. This can be helpful for people with disabilities who have difficulty using traditional input devices. Now, let's take a look at the two types of eye tracking devices. The first type is head-mounted eye trackers. Head-mounted eye trackers are devices that track the gaze of a person wearing them. They are typically used in research and clinical settings, but they're also becoming more common in commercial applications. Head-mounted eye trackers work by using a camera to track the movement of the eyes. The camera is typically located in the center of the lens of the eye tracker. The camera captures images of the eyes at a high frame rate. This allows the eye tracker to track the movement of the eyes in very fine detail. The data collected by the head-mounted eye tracker can be used to measure a variety of things, such as where a person is looking. This information can be used to understand how people interact with their environment. For example, eye tracking can be used to study how people read, how they drive, how they use computers. How long a person looks at something can also be judged using eye tracking, where this information can be used to measure a person's visual attention. For example, eye tracking can be used to measure how long people look at advertisement, how long they look at product labels, how long they look at text on a website. It can also be used to get the direction of people's gaze. This information can be used to understand how people process information. For example, eye tracking can be used to study how people read sentences, how they solve problems, and how they make decisions. Head-mounted eye trackers are a valuable tool for researchers and clinicians. They can be used to study a variety of cognitive and perceptual process. In addition, head-mounted eye trackers are becoming more common in commercial applications as well. They are being used to improve the design of websites, products, and video games. Here are some of the benefits of using head-mounted eye trackers. They can be used in a variety of settings. Head-mounted eye trackers can be used in both research and clinical settings. They can also be used in commercial applications. Second, they provide high-quality data. Head-mounted eye trackers provide high-quality data that can be used to study a variety of cognitive and perceptual processes. Third, they are becoming more affordable. Head-mounted eye trackers are becoming more affordable, which makes them more accessible to researchers and clinicians. Here are some of the challenges of using head-mounted eye trackers. First is that they can be bulky and uncomfortable. Head-mounted eye trackers can be bulky and uncomfortable to wear, which can make it difficult for people to wear them for extended periods of time. Second is Second uncomfortable nature is that they can be expensive. Head-mounted eye trackers can be expensive, which can make them inaccessible to some researchers and clinicians. Overall, head-mounted eye trackers are a valuable tool for researchers and clinicians. They can be used to study a variety of cognitive and perceptual processes. In addition, head-mounted eye trackers are becoming more common in commercial applications. They're being used to improve the design of websites, products, and video games. The second type of eye tracking device is the remote eye tracking devices. They are used to track the gaze of a person without the need for any headgear. They are typically used in research and clinical settings, but they are also becoming more common in commercial applications. These kinds of remote eye trackers work by using a camera to track the movement of the eyes. The camera is typically located in the center of a computer monitor or television screen. The camera captures images of the eyes at a very high frame rate. This allows the eye tracker to track the movement of the eyes in very fine detail. The data collected by a remote eye tracker can be used to measure a variety of things, which includes where a person is looking. This information can be used to understand how people interact with the environment. For example, eye tracking can be used to study how people read, how they drive, or how they use computers, how long a person looks at something. This information can be used to measure a person's visual attention. For example, eye tracking can be used to measure how long people look at advertisements, how long they look at product labels, and how long they look at text on a website. It can also be used to get a sense of direction of a person's gaze. This information can be used to understand how people process information. For example, eye tracking can be used to study how people read sentences, how they solve problems, and how they make decisions. Remote eye trackers are a valuable tool for clinicians and researchers. They can be used to study a variety of cognitive and perceptual processes. In addition, these remote eye trackers are becoming more common in commercial applications. They are being used to improve the design of websites, products, and video games. Here are some of the benefits of using remote eye trackers. They are unobtrusive. Remote eye trackers do not require any headgear, which makes them more comfortable for participants to wear. They are affordable. These remote eye trackers are becoming more affordable, which makes them more accessible to clinicians and researchers. They are easily portable. These remote eye trackers can be easily transported, which makes them ideal for use in field studies. Here are some of the challenges of using remote eye trackers. They can be affected by lightning. Remote eye trackers can be affected by lighting, which can make it difficult to collect accurate data in some environments. They can be affected by head movements. These remote eye trackers can be affected by head movements, which can make it difficult to collect accurate data if participants move their head too much. Overall, remote eye trackers are a valuable tool for researchers and clinicians. They offer a number of benefits over head-mounted eye trackers, including being unobtrusive, affordable, and portable. However, they also have some challenges, such as being affected by lighting and head movements. So now let's take a look at the term resolution. The resolution of an eye tracking device is the number of pixels that can be tracked. High resolution eye tracking devices can track more accurately, but they also are more expensive. The resolution of an eye tracking device is important because it determines how accurately the device can track the movement of the eyes. A higher resolution device will be able to track the eyes more accurately, which can be important for applications such as eye tracking based control. Eye tracking based control is a technology that allows users to control devices with their eyes. This can be useful for people who have difficulty using traditional inputs, such as people with disabilities. The second application is that user experience research. Eye tracking can be used to understand how users interact with websites, apps, and other digital products. This information can be used to improve the user experience by making it easier for users to find what they're looking for and to complete tasks. It can also be used in eye health. Eye tracking can be used to diagnose and treat a variety of eye disorders such as ADHD, dyslexia, and autism spectrum disorder. Eye tracking can also be used to monitor the progression of eye diseases such as glaucoma and macular degeneration. The resolution of an eye tracking device is also important for applications that require precise tracking of the eyes, such as virtual reality, self-driving cars. It is important in virtual reality because eye tracking can be used to improve the experience of virtual reality. By tracking the user's gaze, VR headsets can provide more realistic and immersive experiences. It's used in self-driving cars, where eye tracking can be used to monitor the driver's attention and to take control of the car if the driver ever becomes drowsy or distracted. As the technology continues to develop, it is likely that we will see even more applications for eye tracking devices. Now, next, we will take a look at degrees of freedom. Degrees of freedom is a term used to describe the number of independent ways that an object can move. In the context of eye tracking, degrees of freedom refers to the number of ways that the eye can move. Most eye tracking devices can track the horizontal and vertical movement of the eye, which gives them 2 degrees of freedom. However, some eye tracking devices can also track the rotational movement of the eyes, which gives them 3 degrees of freedom. The number of degrees of freedom that an eye tracking device has is important because it determines how much of the user's eye movement can be tracked. A device with more degrees of freedom will be able to track more of the user's eye movement, which can be important for applications such as gaming. Eye tracking devices can be used to control gaming in a more natural and intuitive way. For example, players could look at objects in the game to select them, or they could look at enemies to target them. Teleoperation. Eye tracking devices can be used to control robots or other remote controlled. It can be used to control robots or other remote control devices. This could be used for applications such as search and rescue, or for operating machinery in dangerous and hazardous environment. Virtual reality. Eye tracking devices can be used to improve the immersion of virtual reality experiences. For example, players could look around their virtual environment by simply moving their eyes. Disability assistance. Eye tracking devices can be used to help people with disabilities who have difficulty using traditional input devices. For example, eye tracking devices could be used to control computers, wheelchair, or prosthetic limbs. The affordance. The affordance of eye tracking devices are the ways in which they can be used to interact with computers and other devices. Eye tracking can be used to select objects on a screen. Eye tracking devices can be used to select objects on a screen by simply looking at them. This can be a much faster and more precise way to select objects than using a mouse or keyboard. Controlling the cursor. Eye tracking devices can be used to control the cursor by moving your eyes. This can be useful for people who have difficulty using a mouse or keyboard. Navigating through menus. Eye tracking devices can be used to navigate through menus by looking at the items you want to select. This can be a much faster and more efficient way to navigate through menus than using a mouse or keyboard. Inputting text. Eye tracking devices can be used to input text by looking at the letters you want to type. This can be a much faster and more accurate way to input them than using a keyboard. Controlling devices. Eye tracking devices can be used to control devices such as computers, prosthetic limbs, and wheelchairs. This can be helpful for people with disabilities who have difficulty using traditional input devices. Now let's go on to the applications. To improve the design of websites and other user interfaces. By understanding where users are looking, designers can make use that the most important information is easy to find, and then the users can easily navigate through the interface. To improve the effectiveness of advertising, by tracking where users look at advertisements, advertisers can learn which ads are more effective and how to improve the design of their ads. Virtual reality. Eye tracking can be used to improve the experience of virtual reality. By tracking the user's gaze, VR headsets can provide more realistic and immersive experiences. Self-driving cars. Eye tracking can be used to monitor the driver's attention and to take control of the car if the driver ever becomes drowsy or distracted. The next topic is the pros of eye tracking. Eye tracking is a natural and intuitive way to interact with computers and other devices. Eye tracking is a precise and it can be used to select small objects on a screen or to control devices with great accuracy. Eye tracking is a non-intrusive and it does not require users to wear any special equipment or to change their behavior. Eye tracking can be used to measure attention. Eye tracking can be used to measure how long a person looks at a particular object or a screen or an area of a screen. This information can be used to understand how people process information and to improve the design of websites. products, and video games. Eye tracking can be used to measure cognitive load. Eye tracking can be used to measure how much cognitive effort a person is using to perform a task. This information can be used to design tasks that are more efficient and less fatiguing for users. Eye tracking can be used to improve the lives of people with disabilities. Eye tracking can be used to help people with disabilities such as spinal cord injuries and cerebral palsy to control computers and other devices. It can also be used to help people with autism spectrum disorder communicate more effectively. Now let's look at the cons of using eye tracking. Eye tracking devices can be expensive. The cost of eye tracking devices can vary depending on the type of device and the features it offers. In general, eye tracking devices that are used for research and clinical purposes are more expensive than devices that are used for commercial purposes. The accuracy of eye tracking devices can be affected by factors such as the user's eyeglasses, the lighting in the room, and the user's attention. The accuracy of eye tracking devices can be affected by a number of factors, including the user's eyeglasses. Eye tracking devices that use cameras to track the movement of the glass can be affected by the user's eyeglasses. If the user's eyeglasses are not properly aligned, the eye tracker may not be able to accurately track the movement of the eyes. The lighting in the room. Eye tracking devices can be affected by the lighting in the room. If the lighting is too dark or too light, the eye tracker may not be able to accurately track the movement of the eyes. The user's attention. If the user is not paying attention to the task at hand, the eye tracker may not be able to accurately track the movement of the eyes. Eye tracking devices are still a relatively new technology, and some users may not be comfortable using them. Eye tracking, this is because eye tracking devices can be intrusive and can make some users feel self-conscious. In addition, some users may be concerned about the privacy implications of the eye tracking. So finally, to conclude the the use and applications of eye tracking devices, eye tracking is a valuable tool that can be used for a variety of purposes. It is becoming more prevalent and accessible and precise, and it is likely to be used far more extensively in the future. Thank you all.